Determinant is actually part of the quadratic formula. And I'm going to have you guys write it just separate, but it is in the quadratic formula. And it's an expression. It's the b squared minus 4ac. So if you guys are looking at the quadratic formula, it does not include the square root. It is just what is under the square root only in the quadratic formula. And that number can help you do a couple of things. It can help you determine how many solutions you have, and then also what type of solution you have. And we're going to talk about this in the lovely little table I have underneath here. So there's three things that can happen if you find the discriminant. What I'm going to do, I'm going to make up a little problem and pretend you full on did the quadratic formula, okay? I'm just making this up. Pretend you full on did the quadratic formula and you ended up with something like 4 plus or minus, let's say I had, I don't know, square root of -5, and maybe that was over 2. I'm just making this up. Okay, the discriminant in that would be the -5. So I ended up with -5 somehow under my square root. What would that tell you about the answers? Like if I were to keep simplifying this, I got -5 under the square root. What would that tell me I would have in my answer? Imaginary, exactly. Okay, so if you've got that negative under the square root, which means the discriminant was negative, this is going to tell you you're going to have I in your answer. Now, does anybody know how many solutions I would have here? 2. So the plus and minus offers you like a shorthand way of writing 2 answers. So it's like 4 plus radical, it'd be I radical 5 over 2 and 4 minus. So this is 2, and then they would both be imaginary solutions here because we would have the I in front of the radical. So that negative under the square root, the discriminant being negative, is going to mean I have 2 imaginary solutions. Yeah.
So the non-imaginary solutions always have to be written separately as 2 answers?
No, like we could have, I'll do another one for that in a second, but like it could be in that format, but maybe this is like a positive 5. That's fine. You don't have to write them as 2 separate answers. You can use the plus and minus. But yeah, so a real solution could look in that format too. It just wouldn't have the I. That's a really good question. Now, if you guys see this, some of the problems will ask you for the number and the type. So the number of solutions would be the 2, and the type would be that they would be imaginary. And then all I did over, and this is not related to that little problem I just made up at all, but if you do have 2 imaginary solutions, just graphically, so you could think about it, and the parabola could turn up or it could turn down, it doesn't matter, but if I have imaginary solutions, your graph would never touch the x-axis. So it could look either one of those formats, but that's just why I put a little picture there. If you don't touch the x-axis, your 2 solutions have to be imaginary. Okay, now, second thing you could happen to you would be, let's say we did our b squared minus 4ac and we got 0. Now, I'm going to make up a full-on quadratic here real quick. Let's say I had 3 plus or minus, and then I had 0 under the square root. I don't know, maybe I have a 6 on the bottom or something. I'm just making this up. The discriminant is what's under the square root, the b squared minus 4ac. If I end up with 0, what's the square root of 0? 0. So really, this is 3 plus or minus 0 over 6. If I add 0 or I subtract 0, it's the same thing, right? 3 plus 0 is 3, 3 minus 0 is 3. So really, this would just turn into 3 over 6, which would just be 1/2. I wasn't trying to, I'm just making the problem up. But what I'm showing you is I just get one answer in that situation. So anytime your discriminant is 0, what you're going to have is 1, and it'll be a real solution, right? I didn't have a negative under the square root, so we're not going to involve I in the problem. So it's just one real solution. Graphically, what that looks like, and these are not the greatest pictures I've ever stolen from the internet, but anyway, it would literally just be that just the vertex would touch the x-axis, and that would be the only point where the graph would intersect with the x-axis. So if you have one answer, one real solution, it'll actually be, bless you, if you get that value, it'd be the x-coordinate of the vertex. if you had the graph. Okay, and then I'm going to take this last group and I'm going to actually kind of split this into two categories. And the only reason I'm doing this is because I want to show you something on the back. Okay, so this one just says we're going to get a positive number as our discriminant. Now there's two categories I want to split that into. Let's say I got a positive perfect square. And the other category, I'm going to say just not. Anything that's not a perfect square. Those are the two categories I'm going to split these into. So if I get a positive number, two categories we're going to fall into here. All right, so I'm just going to make something up like I have been. Let's say I got like 5 plus or minus square root of 81. 81 is a perfect square. Okay, how many solutions would I have there? 2, because of the plus or minus. Now, because that's 81, when I take the square root, that would just be a 9. So what happens in both of these cases, you're going to have 2 real solutions for both of these. Now, here's the deal. If it's a perfect square, then the 2 solutions will be what we call rational, which just means I can write them as a fraction. So basically, if you get a perfect square under the square root, your perfect square for your discriminant, your answers are going to be nice numbers is basically what that means. A rational number just means I could write it as a fraction. Now, when I say nice numbers, like maybe that's 1/3, or maybe that's 6, or maybe it's 2/5 or something. So it could be a fraction, but it would be a nice number. Something that you could write as a fraction. Now, if I don't have a perfect square, again, I'm just making something up. Let's say I had 6 plus or minus, like the square root of 11, I don't know, over 3 or something. All right, now, anything that is not a perfect square, so like any number that you can think of that's not a perfect square, if you take the square root, I'll just do this 11 as an example. This is a garbage number that has a decimal that goes on forever with no pattern. No, I guess it's not garbage. It's just I don't want to insult the number. But anyway, it's not a nice number. It cannot be written as a fraction. So this is what we call an irrational number. So I'm taking in my little example 6 plus or minus an irrational number and dividing it by 3. So you're still going to have 2 real solutions. But these are both going to be what we call irrational, which just means it can't be written as a fraction. So these would be not nice numbers. Like we'd have to round to the nearest 100th or something like that. So if you get a positive number under your square root in your quadratic formula for your discriminant, you have 2 real answers. If it's a perfect square, you have 2 nice answers. If it's not a perfect square, you have 2 kind of not so nice answers. And then again, just to show you guys graphically, oh, I grabbed the wrong marker here. It's not working. This would be a situation where your parabola would cross the x-axis in 2 different spots. It might be at a nice number, it might not be. Is anybody having a question? All right, so all you gotta do, if it asks you to find the discriminant, we're just doing b squared minus 4ac. So I'm just gonna write it so you guys can see it on the screen here. So make sure before you apply this, you have to set it equal to 0 first, just like we would for the quadratic formula. But just identify your a, b, and c values, and you're just going to plug it in. So this first question, if I did b squared minus 4ac, I'd do -6 minus 4 times -3 times 1. I don't really need to include the 1, but this is what we've been doing the last couple of days that I tell you. I just type this into my calculator and don't really think about it too much. Just make sure you're plugging in the right numbers. And I got the number 48. So just immediately, if I get this is a positive number, I immediately know I have 2 real solutions here. Now, if you want to write this, it's up to you. You don't have to. As long as you can tell me that's 2 real solutions, we're in good shape. But is 48 a perfect square? No. So if you wanted to write these 2 real solutions would kind of be nasty numbers. They'd be irrational. That's fine. Or you can just, as long as you know it's going to be 2 real solutions. That's all I'm looking for. If I do the one next to this, my b squared I'm going to do 4 squared minus 4 part of the formula. A value there would be 1, and C value would also be 4. And if you do that, actually you're going to get 16 minus 16, so this is 0. So if you're looking up there, if you get 0 under the square root, that's not the answer, that's just going to tell you how many answers. So this would be the situation where the vertex is going to touch the x-axis. This would be one real solution. And then probably you can guess, but the last one, I'm going to do 5 squared minus 4 times A would be -2 times C would be -13. If you just type that right on into your calculator, you should get -79. Now, that's not the answer, but that being negative, that would be under the square root in the quadratic formula. So I know if I have a negative, that's going to give me a situation where we got I. So this would be 2 imaginary solutions. All right, is anybody having a question about the number and type? All right, now really on the back, all we're going to talk about is maybe like a strategy, like an idea, like what would you use to solve a quadratic equation? If I just threw it in front of you and said solve it, we've talked about all these different methods, what one would you pick? And one thing I want to point out before we get into that, if the discriminant, so what we were just talking about on the front, if the discriminant is a positive perfect square, and I know I told you this on the front, but I'm going to write it again, you have 2 real rational solutions. So I have 2 nice answers, or at least I could write them as a fraction. If that's the case, what that will indicate to you also, the quadratic is going to be factorable, meaning you can use the strategy of factoring. So if you do the discriminant and you find that it's a perfect square, that quadratic you're working with can be factored. Okay, now what I have here, these are all the 5 methods that we have gone through in this class, which this is all there are, for solving the quadratic. When would we use what method? So I'm just going to kind of outline this for you. Graphing, I would say, is probably like, I give you a question and I say solve this by graphing. So not a lot of the time are you going to use graphing, but I would say you could use graphing if you have a graph of, if you have been given a graph in the picture, it says solve by graphing, we could just look for where it crossed the x-axis. So if you have a graph, graphing would be good. If you could use Desmos or your graphing calculator. And graphing would maybe be good if they ask you to estimate the answer, like if they don't want an exact value. Graphing, again, if you had Desmos, your graphing calculator, or if you had a picture of a graph, those would be times that maybe you would graph to actually solve it. Now, factoring, 2 things. If, like I just said, that discriminant, if b squared minus 4ac is a perfect square, you can factor. You would have to do that to determine that. Or if you just want to look at the equation, if you can find 2 numbers, multiply a times c that add to b, just by looking at the question, you can use factoring. Right? You cannot use that on every question. It's just going to depend on the problem. Now, square roots, I would tell you 2 scenarios for square roots, and I'm just going to give you a little example. So square roots, I would say if you have no linear, which would be the b times x term, I would definitely use square roots instead of one of these other strategies. I'm just going to make up a little problem to show you. So I mean, like, okay, let's say we had 2x squared plus 7, I don't know, equals 32 or something like that. I can just get x by itself, take the square root of both sides, and be done. So no bx term, I wouldn't need to factor that, I wouldn't need to graph that, I could just use square roots. The other square root, and I can't really think of a way to like call this something, so I'm just going to give you a little example. But if you have, let's say we had, I don't know, x plus 4 squared minus 2 equals 30 or something like that. That's another situation where I would use square roots because I could just isolate that little set of parentheses and take the square root of both sides. So no bx term in your equation, like that little example there, or if you've got a set of parentheses that you can isolate in your equation, take the square root of both sides. Then you don't have to FOIL, and that'll save you some time. So those two scenarios, I would say, use square roots. Okay. Now, this says this at the bottom, that this method can be used technically to solve any quadratic equation. Now, I had you guys doing completing the square the other day on some problems that, you know, if you like it, that's fine, but deal with like really nasty fractions, really easy to make a mistake. I would say if you're going to complete the square, just as a strategy, I would say if your A value is 1, and your B value is an even number. Because then if I do remember if you do completing the square, you have to do the B value divided by 2 squared. So if that's an even number, when you divide that by 2 and square it, it'll be a nice number. It won't be a fraction that you have to work with. That would be the ideal time, I would say, to use completing the square. Technically, you can use it on any question, and if you don't mind the fractions, please do. But the best time to use that would be if your A value is 1 and your B value is even. Okay, now, quadratic formula. This can literally be used any quadratic equation. And I wouldn't say there's necessarily an advantage one way or the other when you would use this. I would say maybe for me, if the A value was not, just for me personally, if the A value was not 1, like if I had, I don't know, 6x squared minus 10x plus 15 or something like that. So factoring is not always great if you have a number in front of the x squared, even if you can do it for people. So you can use the quadratic formula literally on any question, but I would definitely say, like, if you're looking at it and something doesn't immediately pop to you for factoring or something, I would just go with quadratic formula. Okay, so if we look at these questions here, I'm not asking you to solve, just like which method would you pick of the 5, like for yourself. And it doesn't have to be the same as mine and or somebody else next to you, but like maybe which one would be the easiest. Okay, if I just immediately saw this problem, I might take a second and be like, okay, can I factor this? And if you wanted to say, okay, multiply to get 18, add to get negative 11, like say that to yourself. Or if you want to do the discriminant, you could do that negative 11 squared minus 4 times 6 times 3. If this is a perfect square, that means it's factorable. Okay, so I could factor this. If it's me and I'm not super comfortable with the Berry method, I might not choose that strategy. If I'm in love with the Berry method, maybe I would do that. So whatever you're comfortable with. Also, I would always say I'm just going to write quad form to abbreviate the quadratic formula. You could always use the quadratic formula. If I was looking at that problem, I might try to factor it real quick, but I'm good at the Berry method. I've been doing it for a really long time. If you're not really good at it, quadratic formula will always work. If I was looking at this second question, can you guys think of factors of -8 that add up to 5? No, like it doesn't happen. If you did the discriminant, it's not going to be a perfect square. This is not factorable. I would not complete the square on this unless I was in love with working with the fractions because my B value is 5. You can't use square roots here because I don't just have an x squared. So this one would have to be either graphing, or I would use the quadratic formula if I need an exact value for that. Can't factor that. What would you guys maybe try for the last one here in that row? What would maybe be the fastest way to solve that? Of the 5. For sure. If you've got that set of parentheses, don't FOIL. Save yourself the time. I would just isolate those parentheses, and I would just take the square root of both sides. All right. What about, like down here, I've got x squared plus 7x plus 10. Like, can you, go ahead. Factor, for sure. Like, I would just go, okay, multiply to get 10, add to get 7, like real quick. You could probably do it. If not, you know, I can factor that in 2 seconds. So I would say factor that. If you can, like really quick, think of it. If you're like, I'm not good at that, that's fine. Just use the quadratic formula. Again, you could use completing the square on this, but the b value is 7, so unless you like working with fractions, I would do one of those two, factor or quadratic formula. What would you do for this equation? I got 16x squared minus 1. For sure, you don't have an x term here, so just get x squared by itself and take the square root of both sides, that's all. What about, can you guys think of factors of 17 that add up to negative? No, this is not factorable. Honestly, on this one, I would move that 17 real quick. Because that b value is even, I might complete the square on this. Because my a value is 1, my b value is even, complete the square. You can't factor it. We can't use square roots. We could graph if we had Desmos or a graphing calculator, but not for an exact value. So I would say, again, on this one, either complete the square if you like that method, or quadratic formula, whichever one is faster for you. Okay. Any